All right, so round 2 of the engineering drawings. This time we're with Aaron, who actually I didn't even realize you actually you worked at Boeing and did this shit for a living. So
Sure,
to be honest, we should have had you on first and then Greg come on later. But
well, whatever.
yeah. So actually, the first thing I guess talking to you beforehand, I guess the main thing going over is one thing you said that Greg didn't go over. Make sure this is on that camera. Is these different little number callouts up top? Yeah, I'm not familiar with them at all. So I guess what are these called and what's the significance of these different numbers and letters off to the side?
Those are used to indicate drawing zones on an engineering drawing. The sides are denoted with letters while the top and bottom are denoted with numbers, and it's just an easy way to refer to a specific area of a drawing.
Okay.
So you don't have to say it's this view on this sheet or something. You can just tell them it's zone D3.
Oh,
and
okay.
they can go right to it and find whatever you're referring to or talking about.
Yeah, because I'm sure it's helpful for when you have really, really big drawings with a lot of parts where I could maybe say, okay, the middle one on this small drawing might be a little bit easier, but if I can just say D3, then it's kind of like a coordinate system just for the drawing itself.
It's like a coordinate system in a way, and it does get really helpful with large drawings or even multi-sheet drawings where you have a single part or assembly defined by multiple drawing sheets. Stuff like that really helps to indicate different drawing views and such.
Gotcha. Okay. So I guess that concept isn't too hard to understand. It's just here's the different section. At least, here's a little coordinate system to determine where a specific part is in the drawing. I know we talked, at least with Greg, we talked a little bit about datums, but because at least maybe have you go over as well, and then I'm sure you'll touch on the same notes, but you'll probably have a few different perspectives as well about what they are. And because it seems like from talking to him, since we spent a good half of the chunk of the time on it, it seems like datums are pretty important here, especially with this. I guess because this is where you base your dimensions off of for a given. Given dimension, and then in addition, there's this. I think you were telling me before. There's a significance to why you choose this as a datum because it's a perfectly flat surface.
It's a theoretically perfect surface, and generally speaking, you pick datums you pick features to act as datum features that are maybe crucial to the functioning of the part or whatever.
Okay.
Like a mounting surface is a really obvious one. You could also say use a hole for a bearing journal. That might also be a datum feature as well.
Okay. So
and the axis of it as well.
Gotcha. So it would be, because it seems like when I'm looking at Gregson, it looks like he used a lot of edges for his datums. So I guess for new people coming out, it's I need to choose a datum. It's an edge.
He's using surfaces, but when you call them out in a drawing, you typically show it on the edge. That's the typical convention.
Oh, okay.
An alternative notation you can use if you want to refer to the surface directly is to use something like box, letter line, and then end it with a dot. That's another way you can indicate a datum.
Gotcha.
Surface, or just call out a surface in general.
Okay, so if I wanted to do a datum on, because that looks like it's this. So if this was because this is the side view of the panel. Oh, because you're just mainly restating that this. Are you restating that this is just a datum by? I guess placing it right here.
No, because this. If we were going to do it the conventional way.
That would be.
Way.
Oh, but if you wanted to
These are two different ways of indicating the same surface as a datum. This way right here, showing it edge on, is the usual way it's done, though.
Okay, gotcha. So and then I guess I'm sure that's for significance for the machinist in general to make sure that, okay, this surface is perfect because you're basing all your measurements off of that.
Well, that's what they're going to measure from, yes, especially any sort of basic dimension that's being dimensioned from that particular datum feature.
Okay, gotcha. Okay, well, I think between yours and Greg's, I think people should have a good idea of, now we know what a datum feature is. This is how you choose where to put it now. So then, let's see, going from there, we also talked about Greg, at least I talked to Greg a little bit about this, but it sounded like, again, talking with you about this beforehand, there's a few other things that maybe just it's extra clarification or what each of the symbols mean. Going over this hole here, So yeah, we're familiar. Most people who've taken like an ME 116 class or basic SolidWorks classes, they have like, okay, when you're putting holes and they're the same holes and they have like a pattern to them, you would state them as, okay, 4 holes. This is the type. So this is an M3.
Well, if you have multiple holes that are the same dimension, or you have some sort of feature that appears repeatedly in a drawing view, you can put 4 or some number X and then call it out once. This way you don't have to call it out every place you see it at.
Yeah, you just say, and now did they all they have to all lie in the same plane when you're doing that? Like, for instance, if I had, because I have 4 holes, I have like 4 holes here. But then let's say I had maybe 4 more holes on the inside of this plane. Like if they were cutting through straight this way, is there a way I could state that there are 8 holes now that they're just on different planes? Like for instance, I'll grab you, like the metal part. So if I had, we'll probably end up doing this. If I had 4 holes going through this part, we would obviously state it like this. We have 4 M3 holes, but if I wanted to state that they were 8 holes, 4 here and then 4 coming through here, is there a way I could do that, or do they all have to be on the same plane?
Wait, what do you mean 4?
Like 4, like I drilled in here 4 times, so now there are 8 holes in total. But,
that they're all the same. Yeah, you would need to call them out in a separate view. You have one view to indicate the holes going through the edges, and then another view showing the holes here.
Okay,
you would need 2 separate views to describe them.
Okay, so that makes sense. So yeah, so for a given, like the top view here, you would list these 4 holes, but then for whatever reason, if you were, I guess maybe you're like mounting something on the other side, if you were to do 4 holes here, you would have to go to, let's say, this view and then call out those 4 holes separately.
If they were through holes, it wouldn't matter which view you were calling them out from. But if they were blind holes, like if you had 4 holes on this side going a specific depth, but then you were drilling blind holes from the bottom side also at a depth, then yeah, you would need to call them out in separate views.
What's the difference between blind holes and through holes again?
Blind hole just goes through a specific depth. It doesn't go all the way through.
Oh, okay, that makes sense.
A through hole goes all the way through whatever material. Blind just goes a specific
depth. Yeah, okay. Okay, that makes sense. So let's see. Actually, since this is the one that looks the most involved, because you and Greg went back and forth a lot with the drawing views, were there any areas that you had to, like, I guess, correct him on, at least for the drawings? Because I know he gave you the drawings and had your input. Do you remember the things you gave him input back on that he ended up adjusting on here?
On this one,
even on, not even necessarily this one, but maybe on all 3 of them together.
The most common thing I saw was that I thought he made his drawings a little small. He was using A size for a lot of stuff when he would probably be better doing B or C size, and have more room for all his views, and also be able to spread his dimensions out a little bit so they weren't all crammed together in the drawing.
Gotcha. Okay, because instead of like instead of like shrinking the text on the dimensions and then really cramming it together, if you just upped the sheet size, then it just gives you a lot more room to work with.
Yeah, it just helps, and cramming everything together is generally harder to read, and for a lot of parts, you generally need a fairly large sheet.
Okay.
Like at Boeing, I don't think I ever usually worked on drawing sizes smaller than a D size.
Oh, wow, dang.
Yeah, the only time I ever went smaller was to make a template drawings, and those, they aren't dimensioned and are drawn at, full scale.
Yeah, that makes sense, yeah.
But other than that, I usually use fairly large drawing sizes.
Okay, so is your suggestion that we, from now on, we need to start using D sizes?
No, you don't have to go that big. I mean, like, on these, I would probably use a C size to do this, or even maybe a B size as well if it was a pretty simple part.
Okay. Gotcha. So split B and C is kind of a good range where you have a lot of room to work with. And then
yeah, A size is ideal where you have a part with a constant cross section. You only need like 1 or 2 views to describe it.
Gotcha.
Like a shaft or something. You only need one view for the cross section. You can call out the length, and you're good to go.
Gotcha. Okay, so one thing you gave him feedback on was, okay, you make your drawing sizes a little bit bigger because now you have more room to play around with. Was there anything else you gave him feedback on? Like, I know, for instance, maybe it wasn't necessarily on the drawing, but I know on the model design, you ended up giving feedback on the little hole. End up drilling the edges of that a little bit.
That was something driven by the machine shop we were going to, because they were running into an issue machining these slots where the shank of their drill bit would hit this wall before they could finish the rest of the slot. So it was suggested to just, when they got to that point, swap out the drill bit they were using with I think it was an 1/8 inch bit, because that was the smallest shank size they had, and finish the slot with that so it could go all the way to the end.
Gotcha.
Like we needed to.
Yeah, and actually I think Greg, specifically on this one, wrote that he took this feature here and called it out in this detail B part. So maybe get better for the camera here. I did talk to him a little bit about, because this is all in metric, and then we end up calling out an imperial unit here, that at least he suggested that you be explicitly clear that this 1/8 inch is in an English dimension. At least it's an English dimension on a metric drawing, so he wanted to just be explicitly clear about that. Do you know if there's any other best practices for if we have situations
mixed
like
dimensions on a drawing? I think that works. Just making very clear in the call out that you're calling out a dimension in a different measuring system or unit system.
Gotcha. And that's pretty much it. Pretty straightforward.
Yeah.
Okay.
State it really clearly. Make sure whoever's reading it knows that. I mean, just a note like that works. I can't think of any standards or conventions offhand. But just at the very least stating that clearly for whoever's reading it.
Gotcha. Okay.
And this is something you could change later on in the future too, if we have a different machine shop that can just drill the slot at the same thickness the whole way through without having to do a drill bit swap right at the end.
Yeah.
Then we could get rid of that view entirely because it wouldn't be necessary.
Yeah, gotcha. Well, I think actually Greg in his latest model ended up doing that. But yeah, at least this is a good example for people who are making engineering drawings in the future. If they have a clash of systems, how exactly do you specify? So yeah, this is just a good practice in general. So so we have you told Greg increase the drawing sizes. You made the suggestion about drilling in the hole, and this is a pretty good standard for if you have a mix of different systems. Do you remember any other inputs you gave to Greg when he gave you the drawings? He's like, okay, here they are, and you're like, oh, you've maybe forgot this dimension, or this. You could state this dimension in a different way.
Oh, there were some were just small things. I remember. I remember on the drawing. Okay, it's not here. He had to call out some reference dimensions, or some dimensions as a reference, and he was using boxes similar to what you'd see for a basic dimension, which is not convention at all. At least I've never heard of anybody calling reference dimensions like that. Usually you put them in parentheses to indicate that.
So reference dimensions are, if I remember correctly from our conversation with Greg, if you have here's the main dimension, because you usually state the dimension on. You submit the dimension on the view that best describes, I guess that said dimension, that's the right way of putting it. So on the top part, it's easier to see the width of that on the top part versus if you took a side view, you can kind of see that, but it's better to put it here. Well,
that's dimension placement. Reference dimensions let you call the size of a feature or something without that being an authoritative call out. One thing that gets around is double dimensioning. In general, when you're making a drawing, you only want to call out the dimension of a feature once. You don't want to dimension the same feature multiple drawing views.
Gotcha.
That can lead to ambiguity or confusion. And so if you need to indicate the size of a feature that's already been dimensioned in another view, you can put a reference dimension there. That way whoever's reading it can quickly remember what size it is or how far away
and the way you denote a reference dimension is you put the box around.
No, you put parentheses around it.
Okay, so this is, if that's the case, then this is not a reference dimension then.
No, that's a basic dimension. That's a GD&T thing. You use that on any dimensions that are, in this case, it's dimensioning a feature that is being controlled by this positional tolerance and being dimensioned from a datum feature. This has to be a basic dimension because now its tolerance is being affected by the positional tolerance and not any general tolerance or a specific one placed on the dimension.
Okay, so and then when you say, I guess when you say positional tolerance versus, I think, specific tolerance, what's the difference between those two?
Positional tolerance is this tolerance that's being called out in the feature control frame here, and that's just one kind of geometric tolerance, or well, not a geometric, it's a positional tolerance, and it's basically overriding other tolerances and affects the location of that hole, basically, or it controls the location of that hole now.
Okay, so positional tolerance, like you have like the general tolerance is like, okay, for most parts in general, you keep it at, like in our case it was like 0.1 millimeter, but if you have a positional tolerance, that overrides the general tolerance.
Well, in this case, it'll override it. It'll affect the dimensions determining its location. The actual size will be controlled separately. Here in this case, since this is going to be a threaded hole, that's just going to be based on however you drill this hole to support a M3 fastener or M3 thread.
Gotcha.
But its location is going to be controlled by this positional tolerance.
Okay, and then the positional tolerance, I guess just to make sure, because these are actually all new terms I'm learning, right? That's this whole box right here. That's just like, okay, it's centered. It has a 0.1.
Well, we have a positional tolerance. The tolerance zone of its axis lies within an imaginary cylinder with a diameter of 0.1 millimeters, and it's to be measured relative to datums A and C.
Okay, gotcha.
Yeah, there's quite a bit of information contained in those.
No, definitely. Hopefully we'll make simpler models in the future so we don't be... Well, I'm sure there'll be some complicated things we call out. But yeah, having never seen a lot of this stuff before, I'm like, position. I didn't even know there's a difference between positional and then general tolerance, and then there's names for all that, and then...
Oh, yeah. And that's not even including all the types of tolerances in GD&T. It's a whole other beast in and of itself.
Gotcha. Well, for people, because I guess maybe myself included, who we're like, I'm just like new to it. Like I'm like familiar with like, okay, tolerance just as a general idea, but you have all these different specific. I think what the standard is, the GD&T is the standard.
That's just what they call this kind of dimensioning that controls both form and orientation beyond just basic tolerances like this one right here.
Okay.
Because you might not be concerned about, say, if you have a surface that has to be machined within some sort of range of size, you might not be concerned about its variance locally at each point, but you are concerned about its orientation relative to another surface or something like that.
And it's amazing, like the more I get into engineering, the more I didn't realize like how much detail there's placed into like figuring out what holes need to be drilled where. Like I thought it was just like, oh, you just put a hole here, and then it's just like, no, now we have like 200 terms to describe.
Yeah.
Just like this needs to be exactly there and no different. Gotcha. Okay, so then because I know you went to school formally for this, so like you already had teachers who taught you for 2 years and gave you textbooks. If somebody wanted to like at least get like maybe 80%, like find like maybe one or two good resources where they won't obviously learn it as in depth or maybe as much detail, but they want to get like a good overview of like, okay, positional versus general tolerance, or all these datums. Do you know of any good resources off the top of your head where they could go to learn that stuff?
Well, depending on how much money you want to spend.
Gotcha.
You could just get the official copy of the standards that control this, ASME Y14-5.
Okay, yeah, I think Greg was suggesting that.
Of which 2009 was the most latest year it was revised, and that's the current GD&T standard in force right now. You could read through that, and that would explain straight from the horse's mouth how all this works.
Do you know? Yeah. So that's, and I think there's some free copies online. Do you know if there's any more? Like, because that's gonna be the big, in-depth, comprehensive guide. Anything more, like maybe even for like the free side, or maybe like there's like a good like quick overview guide that people can go to as well?
If you're able to, you can find like a pocket reference manual for cheap or something like that.
Okay.
That's another source. It'll explain what every term and symbol and everything means, and even give some examples of how they're used.
Okay.
And then, of course, you could always just Google and find what other websites are most helpful to you. I can't really think of any offhand.
Do you know what they would Google to find that? Like, would it just be like
you could just Google geometric dimensioning and tolerancing and find any websites that don't charge you to see their explanations for stuff. I don't know any really good ones offhand.
Yeah, but at least I just want to know like the search term people would put in if they want to go deeper on
that. That will work right there. Just geometric dimensioning, tolerancing in Google. That'll give you plenty of results right there.
Gotcha. Okay.
So Engineer's Edge, that's a website I remember offhand that I went to a lot.
Okay. Gotcha. And that's just what you find yourself like when you had to remember, oh, okay, I have this hope, I need to figure out how to call it out. You went to like Engineer's Edge or
I just forget something, I need to remember the convention or how to call it out, or if I'm even using it properly.
Okay, so Engineer's Edge for you was a pretty good place.
That was a good one. There was I can't remember many other websites offhand. I've acquired a few pocket reference manuals over the years, so I've had that to refer to. So,
do you know what those pocket reference manuals are called, or what they would search to find those pocket reference manuals?
Just GD&T reference manual or something to that effect.
Okay, gotcha.
Just Google or go on Amazon. I'm pretty sure there's a million different ones on sale. Just find one that price is right and
won't break your budget. Cool. Okay, I think that should be a pretty good overview, unless, because you already talked about giving feedback to Greg, the size of the sheets, the specific, I guess the tip you gave to the machine shop about how to solve that problem of getting the bit to the edge and then not
it was just a suggestion. I wasn't sure they could do it or not.
Yeah.
I just asked them what was the smallest shank on their drill bits, and could they just finish the slot at that diameter to
Yes, gotcha. So you gave those two pieces of feedback, and then you got into, I guess, the real deep minutia with Greg about how to call out, I guess, different types. Like, so you said this was like a reference dimension versus, I forget the other name you used, that has the parentheses. The reference dimension has a parentheses versus this is like a...
That's a basic dimension. And that's a GD&T thing. That's how you call out basic dimensions. That's the theoretically perfect dimension that is being controlled by whatever geometric or form or location controls you're placing on it.
Actually, I guess maybe now we're on like dimensioning and a little bit on tolerances. Do you know when people are choosing tolerance values, is there any good rule of thumb that they should go to approaching that? Because I know when Greg was talking to me about it, initially he said, make everything 0.1, but then he found that ended up being profusely expensive. So then he just said overall make it 0.1, and then different things he adjusted. Do you have any tips?
It's just going to depend on the capabilities of your machine shop or wherever you're having this manufactured and your equipment, and also just based on your own experience. I don't know of any particular rule of thumb offhand.
Did they just give you, like at Boeington, did they just give you dimensions to base everything? Because for a lot of the parts that you're dimension, you're not physically working with necessarily, so you don't know what...
they already knew. They had a whole army of people that could figure all that out.
So they just gave you the numbers.
They gave me the numbers. They knew their equipment. They could tell us how precisely things needed to be made. I mean, there was a lot of people that were involved in that sort of decision making. I didn't really have to do too much myself to know what kind of tolerances were needed or whatnot.
So that's just more, if you want to figure out tolerances, it's just more comes down to, especially since we're designing and then creating the engineering drawings, it's more of a, you have to self-reflect.
Are you talking about general tolerances, or just tolerant, or like on a title block, or just any sort of tolerance?
I guess I'm more approaching it from like when I'm designing something, I need to figure out what tolerance to put it at.
Well, that's just going to depend on how much variation you're willing to allow, because half the reason we have tolerance is just to account for the fact that you can't make anything perfectly sized in real life.
Yep, yeah.
And so it's just a matter of how much variance
are you willing
to allow.
To do.
I mean, for some features, they can have a lot of slop to them because they don't critically affect the function of the part, so you don't need to have a real tight tolerance on them. Other parts or other features might be extremely crucial, so you got to tighten them up a lot to make sure this thing can work how it's supposed to.
Gotcha. Okay. And then when you say a lot of, is there a number when you say a lot of slot? Like for us, it's for instance.
That just depends. Like a 1 inch tolerance might be a lot for a part that's only 3 inches long. But if you got a shaft that's a foot wide, 1 inch.
So it's just it's relative.
It's all relative. It's just going to depend on what you're designing, what your manufacturing capabilities are. There's a lot of different things that go into determining tolerances. Sometimes it's not that important. Other times you have to do a lot of research to make sure.
Gotcha. Okay, so yeah, just really comes down. I guess so. Yeah, getting back to the main thread. So then telling Greg how maybe specifically to point out those two different types of tolerances. Do you remember? Again, I guess now we have like 5 or 4 minutes left. Do you remember were there's anything really big that jumped out to you that you had to give Greg feedback on, that you want to make sure if someone else has to do these drawings that they pay attention to?
Was there? I don't know. It was a while since I looked at him. I'd have to go back and look over my notes I gave him.
Okay. Actually, if you have those, you could just send them to me, and I can maybe just upload those as a resource for people if they want to look at them.
I can. Yeah, it was something I sent him to him through Slack. I'd have to go back through my DMs with him.
Okay, gotcha. But okay. But it sounds like with what Greg said, and then the tips that I guess you gave to me now, if people followed those things, and then again going to the reference guides, if they followed those and gave it to the machine shop, they shouldn't have too many problems for getting the machine shop to interpret what you're trying to tell them to do.
I guess.
Okay. I guess what's missing from then?
I haven't seen Greg's whole video yet, so I don't entirely know what else he went through. I mean, there's a lot that can go into an engineering drawing.
Okay.
I mean, it's not just having technically accurate information. This is your main mode of communication with your manufacturers.
Yeah.
So other things include things like readability, layout, making sure it's easy to follow.
Okay. Yeah.
There's a lot of different things I could go into on that.
Gotcha. Okay, well, I'm going to have to bring you back then, I guess, once you've looked through Greg's video. But I think it gives people, at least for this round, to work off of and, I guess, dig into. So, perfect. All right. Well, there you go. More crash course about a billion things you didn't even know you needed to know about engineering drawings. So, yeah. Thanks again. And I guess if you guys are watching and you have to make engineering drawings, have fun, because there's a lot I guess you have to go into.
Yeah, there is. You'll learn a lot of it. You just learn on the job and all that. Because a lot of things you have to do are going to be based on where you work and what they do.
Yeah.
And what tools they give you. I mean, they might have you use CAD programs. They might just give you a flattened box and crayons, and you got to use that. It's just going to depend.
Gotcha. Oh, actually, speaking of the CAD, so I'll end it off the video, but then we'll go into the, the computer version of it really quick here. So the call-out thing you're suggesting that he does, if I remember correctly.
Oh, Greg he was having trouble remembering how to do multi-liters, if I remember correctly.
Yes, if you have a note and you want to point at 2 different spots.
Or multiple spots, yeah.
Yeah, escape. So if I remember what you showed me, so we go to...
You just select your note right there, click on it, so the property box, and then go...
This guy.
Yep.
So we click leader here.
And then just plop your leader down wherever you need it.
Yeah, so we grab, that, and then let's say, okay, I want to call this, let's say I'm making, okay, obviously it's a rectangle, but I want to make it a square, and I want to say both of these edges are, 5 inches. If I remember right, you right-click, actually, hold on, right-click the line.
The leader line, and then you click Add Jog Point.
Add Jog Point, that's what it was.
And then just click somewhere on the leader line to indicate it, and then click on the jog point you made, or right-click on it.
And then Insert New Branch.
Yep.
Cool, and then you click the other part, and then if you want to have 2 lines, just a small detail, but that's how you do it in SOLIDWORKS.
Yep.
Cool. All right, I think I've interrogated you enough for today, so... Yeah, thanks again.
All right.
You are forever immortalized in Cougs, YouTube history. So
wonderful. Great.
Don't enjoy it too much now.